Okay, video lecture 2.1. We're going to start out chapter 2, and you can see from the picture here that we are looking at analyzing data. And so this is maybe the most important chapter of the entire year in some ways, because we are going to set the foundation for the type of statistics we'll use, for the way that we treat our numbers, and the way that we round our numbers. And so this is an incredibly important chapter. It is not a particularly exciting chapter, so I might get a lot of these faces as we go over this, but I need your effort nonetheless. This is a very important chapter. Things in this chapter we'll deal with the entire course of our school year in chemistry. So the first thing I want to mention are units, and units are incredibly important. If I tell you I have 100 of something, I better tell you what the something is, otherwise it is meaningless. And so units are a very, very big part of any science, but anytime you say a number, we need to have some units here. So the science goes off of what we call the International System of Units, or the SI unit system. It is a base 10 system. It's which is the metric system itself. So it's based upon the metric system, and it's really nice though to be able to convert in between units, because they're all just factors of 10, which ultimately means you're just simply moving the decimal point. When we talk about units, there are two basic types of units. There are fundamental units and there are derived units. Fundamental units are defined by a physical standard of measurement, meaning it's a basic unit that we can use. When we talk about the length of the meter, there is an actual meter, a stick somewhere, I think it's in Europe, that it defines what a meter is, and everything goes off of that. The picture in the top of your screen there that you'll see is the picture of a kilogram. And that you see is encased in glass to keep it from changing. But that's what we base everything off of. And we notice that the fundamental units here for mass is kilogram, length is meter, temperature is Kelvin, which we'll talk about later, the amount of substance is the mole, time is in seconds, electric current and luminous intensity are not nearly as important. Now there are a lot of other units that we'll see and use. These are called derived units. These are combinations of all these fundamental units. So some great examples are area, which is typically length times width. And so that would be the length squared, and so you'd have meters squared. Volume, density, there's a lot of these that we'll see. You can see the derived unit is some combination of all those fundamental units above. Area being meters squared, so it's a combination of length twice, volume meters cubed, length 3 times, and then we see density then. Density, if you remember the equation, is mass divided by volume. We'll cover that very soon in chemistry, but if you look at mass and volume, mass is kilograms, and volume, not included on that table above, is typically meters cubed. So there's a lot of derived units, and these are definitely not all of them, but they include quite a few of our derived units. Thing I want you to understand is fundamental, and I need you to know what those fundamental units are, and then know that derived is some combination of those. So now we get into the fun part here, and we only have 2 more slides left to cover, but each of them take a little bit of time. If I want to convert feet to inches, I know what I use. I use something I already know, which is that 1 foot is equal to 12 inches. That is called a conversion factor. It's a ratio. 1 foot over 12 inches or 12 inches over 1 foot, it means the same thing. The ratio is always equivalent to 1. And this is derived from an equality between the different units. And so again, the ratio is 1 foot over 12 inches or 12 inches over 1 foot. Ends up being the same thing. They're both 1, but they are derived from an equality, knowing that 12 inches is equal to 1 foot. And this is what we use to convert one unit to another. So it'd be a great question on a quiz would be, what do we use to convert units? It's a conversion factor. And so there's several examples here. 1 week equals 7 days, and then in parentheses you can see that it becomes a ratio, 1 week over 7 days or 7 days over 1 week. Same thing with feet to inches. 1 foot equals 12 inches, so we could have 1 foot over 12 inches or 12 inches over 1 foot. And you see a few other examples there with quarts and gallons and meters and centimeters. And so again, here is a bunch of equalities, and there we see on the bottom that a fraction between liters and quarts could be given as that. So anytime we know an equality, we can use that as a conversion factor. I'm going to say that one more time. Anytime we know an equality, we can use it as a conversion factor. And so here's a little example. Moles and liters may not sound too familiar, especially moles right now. But what we're seeing is that you start with a value, and that's what we're seeing here in the green arrow. We start with 49.7 liters. And what we're trying to go to, the end on the right side there, is we want to know how many moles that would be equivalent to. And there we see in the middle is the conversion factor. And what that conversion factor is telling us is that 1 mole is equivalent to 22.4 liters. So if we look over to the side table here, if this was included in this other example, it would say 1 mole equals 22.4 liters. So that's what we're using, and it is looking like a fraction. Get used to it. We're going to use a lot of fractions here. Now the rest of the problem you don't have to worry about now, but you notice that they give you the answer and then they round it and they're telling you about significant figures. That's a little foreshadowing of what we'll look at in the next video lecture. Last slide I want to mention here has to do with converting units using the SI prefixes, and this is something that'll be definitely a new thing, and we'll look at it a lot in class, next class. Since SI prefixes are powers of 10, all we have to learn is how to move the decimal. So ultimately we just have to figure out which way we move the decimal and how many places we need to move the decimal. And so again, SI, it's showing you differences in terms of powers of 10. If we look at it, everything on the right side other than that third one there are all in terms of meters, and we see 1 centimeter equals 10 to the negative second power of meters. So what that's telling you is that it's all base powers of 10. Everything we'll deal with are base powers of 10. And so before we actually look into looking at the SI prefixes, I think we need to look at just a basic conversion factor here. And this might help us to see how this process works. So first off, we're going to say, let's say we measured something and we found out it was 42,650 feet. Well, we wanted to know what that would be equivalent to in miles. And so we need to start with what we're given, and then we're going to multiply it by our conversion factor. So we start with what we're given. This is just like we saw on the last slide. We start with the number we have. Then we need to multiply by our conversion factor. And hopefully you know that a mile is the same as 5,280 feet. And so when we set up our conversion factor, we need to figure out, do we put 1 mile over 5,280 feet, or do we put 5,280 feet over 1 mile? And ultimately what we're trying to do here is change the units. We want to go from feet to miles. Of course the number is going to change, but it's the same value, just different units. So the units we want to obtain here are miles. Anytime you use a conversion factor, the number or the units that you want to have need to go on the top. So we're going to put 1 mile on top, and then we're going to put 5,280 feet on the bottom. Now hopefully what you'll see here is as we multiply fractions, you multiply the numerator straight across, the denominator straight across, and on the top and on the bottom you're going to have feet, which mean that those will both cancel out, and we end up with 8.078 miles. Now that's the old method of converting feet and miles. Feet and miles are what we're used to. But what we'll use in science is going to be SI prefixes, which ultimately means all we have to do is move the decimal place. So while that problem wasn't necessarily difficult, it was a problem that involved knowing a conversion factor, and a conversion factor that was kind of a interesting number. 5,280 is not exactly a simple number. So now we're going to look at this other method of looking at meters to kilometers. Well, we can go about it doing the same exact setup that we've done before. We start with what we're given, 42,650 meters. And we can set up a conversion factor if we know how many meters are in a kilometer. And that's great. but there's something that we can do here. We can change this by a power of 10. And so if we look at our handout, we're going to see that kilo means 3. It means 1,000. It means a power exponent to the third power. So kilometers are 3 powers of 10 bigger than meters. So if I want to reflect this, I need to move the decimal back 3 places. And so that's where I'll be looking. So then we see that 42,650 meters is equal to 42.650 kilometers. Now that may not have clicked with you. We will go over that in class. But what I really want you to see here is the simplicity. Using the old English system, we had to do a conversion factor and plug it in our calculator. Here, all we had to do is move the decimal as long as we understand how. And that's what I hope to show you next class period. There's a very important rule of thumb. I want you to remember this. I'll refer back to it a lot. If the unit gets bigger, the number gets smaller. And so if we look at this, this is an example of that. We were going from meters to kilometers. Kilometers are bigger, so the unit is getting bigger in our final answer. That means the number had to get smaller, and we see it went from 42,000 to 42. The opposite is also true. If the unit gets smaller, then the number itself will get bigger. So that's it for this first video lecture. Please come with questions. We are going to work examples and take a look at this next class period.